Hi everyone, it's Ms. Chow, and today we are starting the section on polynomials, which is chapter 5. And the first section of chapter 5 is 5.1, defining a polynomial. So if you don't know what a polynomial is, you will by the end of this video. So let's start out here. What are polynomials? Well, polynomial comes from the Greek word poly, meaning many, so that's, we see poly all over the place. And then nomials. Well, nomials is from the Latin, and it means names actually, but mathematicians have somehow found the translation to terms. So polynomial means many terms. So I have down here an example of a polynomial. 5x cubed minus 3x squared plus 15x minus 6. Now this may make you want to vomit, but don't, because it's really not so bad, and I'm going to explain why. Okay, the first thing we're going to talk about are variables. So variables are things that really, you know it's a number, but you don't know what number. So that's things like x, and y, and z, and t, and s, and whatever else you want to name your variable, but it is the unknown. So that's the variable. The term refers to the whole element here that is part of this math sentence. So 5x to the 5 is a term, and minus 3x squared is also a term, and 15x is a term, and minus 6 is a term. So you notice I actually included the minus sign when I talked about the term. That's pretty important. So if it's a positive, it's just positive, but if it's a negative, it has to be included. Okay, and then moving on, if you're ready to move on. Oh, the last thing I want to talk about with this was coefficient. And the coefficient is the number that is right in front of the variable. So that would be the 5. Or in this case, the coefficient is negative 3. And in this case, the coefficient is 15. And in this case, the coefficient is minus 6. Okay, so let's move on to, now we've talked about variables, which was your x, and terms, which is the whole unit, the whole component, and then the coefficient, which is the number in front of the variable. So let's look at this one then. In this case of 3x squared, what's your variable? So your variable is x. And you could say x squared, but it's the variable itself is really x. And the term, well, the term is 3x squared, that whole term. And then the coefficient is the number in front of the variable, so it's 3. Okay. Let's do another one. Oh, this 9a squared is not right, but I'll fix it up for you. So if we do this, and then we do this, and we have, all of a sudden we have this squared thing. Okay, so 9a squared minus 5. So now, what is the variable here? Well, the variable is a. Oopsie, it's not working. The variable is a. And then, sorry, there. And in this case, this one, there isn't a variable. And in this case, this is called a constant. Okay. So the variable is the a, and the coefficient is the 9, and the term is 9a squared minus 5. And so minus 5 is the constant. Okay. How about in this one? What's the constant here? Well, the constant is pi. So you can have pretty much anything for a constant. You can have minus a half, you can have pi, you can have whatever. But it doesn't matter that it's not a rational number. So the variable is y, and the term is 3y cubed. In this case, it's minus 7y is the other term, and pi is the third term. So there's three terms, because they're separated by plus or minus in any case. And then the last thing we want to know is the coefficient. So the coefficient is the number in front of the variable. So in this case it's 3. In this case it's minus 7. Sorry, you can't see that very well. Let's do a little erasing. How about that? Okay, so in this case it's minus 7, the coefficient. And in this case, I guess you could say the coefficient is pi, because you could say this is pi y to the 0. Well, a variable to 0 is really just 1. So the y to the 0 falls off, but really you still have the constant is there, and it could be seen as the coefficient of y to the 0. Okay, let's just see if how well you could think about these. So I'm going to give you some examples. So suppose well, before I do that, let's go this way. Okay, I want to explain another term or two. So if we have something with one term, like this says one term, that's called a monomial, M-O-N-O, monomial. Okay, and mono means one. So 3x squared, that's a monomial. Now this one, how many terms does this have? Well, it has 9a squared and it has minus 5. So that's got 2 terms. And it doesn't matter if there's no variable associated with it, a component with a term, it's still a term. So 2 terms is called a binomial. Okay, so it's got 2, bi meaning 2, mono meaning 1, and bi meaning 2. And this, what do you think this is going to be? This has got 3 terms, 1, 2, 3. So 3 terms is called a trinomial. M-I-A-L. So, and you know that from like from bicycles. Think about bi is 2, bicycle has 2 wheels, tricycle has 3 wheels, trinomial has 3 terms. Okay? So, and that's what we've talked about here, is what's a monomial, what's a binomial, and what's a trinomial. So let me give you some examples then. So if I said this is a polynomial, is that true or false? 5. Well, it's true. It's true because it could be 5y to the 0, and it is a term, and so it is a polynomial. And it's also a monomial. And then suppose I'll do a different color, x cubed plus 3x squared. So is this a polynomial? And the answer is yes. And the answer is also a binomial. And then another one. So how about 3 plus x squared minus y? Is this a polynomial? Well, it is, and it's called a trinomial. M-O-M-I-A-L, trinomial. Okay. Now, how about, we're going to go down below here, just sort of see. How about if we said, okay, we have y to the minus 5 plus y to the minus 1 plus y to the minus 7. Okay. Well, it's got three terms, 1, 2, 3. But look at the exponents. So polynomials, you cannot have negative exponents. So they have to be whole numbers. So exponents have to be 0 up and integers. Okay? They can't be fractions, they can't be negative numbers, they can't be anything like that. It has to be whole numbers from 0 on up, integers. Okay, I'll give you another one. How about minus 3x squared plus 2x plus 4? Okay, is that a polynomial? Well, it sure is, because this minus 3 over here, that's the coefficient. That's considered the coefficient. And 2 and 4 are also coefficients. So this is a trinomial. And it's valid. Okay, how about x, let's see, 3x to the a plus y squared plus 4xy. What do you get from that? Is that a polynomial? Okay, and you may be inclined to say yes, because it's got these three nice terms, and it seems to be doing fine, except that you are also, another rule is that you are not allowed to have a variable as an exponent. So your exponents have to be 0 and greater, and they can't be variables. Okay? No variables. Okay, I think that's pretty good. Showing you what are polynomials. I think I'll erase a little bit again. What are polynomials? And then down here, my point was to talk about what are not polynomials. Okay, so, and we've talked a little bit about that down below here, where we've said, okay, we've looked at some examples of things that are not polynomials. So in this case, I don't know if you can see very well on your screen, but that says 5x to the minus 2 minus 3x plus 7. So because you have an x to the minus 2, that means this cannot be a polynomial. And here, similarly, so 2x to the 1/2 plus 3x squared minus 2. Well, in this case also, you have x to the 1/2, which is not an integer, so it cannot be a polynomial. Okay, here we have 9 to the square root of a. Well, that actually is the same as 9a to the 1/2. And that's the same as that. You cannot have a polynomial with a fraction in the variable exponent. And then finally, the last example is 9b to the a. Well, that is b to the a, and we talked about that too, where you can't have a variable as an exponent for a variable. So this can't be a polynomial either. Okay, I'd like to do one more thing to make sure you're prepared for what's coming up in the lesson. And that is just to go over a couple of examples of things. So for instance, if we have a polynomial that looks like this, first of all, what would you call it? Is it a polynomial, a binomial, a trinomial, monomial? What is it? So it's called a trinomial. And that's because it has 3 distinct terms. And we'll write them in this box here. It's similar to what you have it for your homework. So the first term is 4x cubed. And the next term is minus 2x. Don't forget the minus. And the last term is 8. Okay. And the degree of the term, well, the degree is 3. Here the degree is 1. And here I guess you could say the degree is 0. And the leading term, well, what's the leading term in this trinomial? Well, it's 4x cubed. And the degree of the polynomial, in this case, because the variables are all the same, just x, the degree of the polynomial is the exponent of the highest number. So the degree of the polynomial is 3. Okay, let's try another one. Okay, this one is this a monomial, binomial, trinomial? You have x squared y, but that's really just a single term. So in this case, it's a binomial. And it has 2 terms. So term 1 is x squared y, and term 2 is negative 2. And then the degree, well, the degree is in this case, because there's 2 different variables, you add the degree of both the variables, the highest variables. So the degree here is x is 2 and y is 1, so that's a 1 there. So the degree is 3. And the degree of minus 2 is 0. And the leading term, well, the leading term is x squared y. And the degree of the polynomial is 3. Okay. And the last thing, polynomials are written in descending order of powers. For example, you have 6 minus 3x squared plus 3x. We would write that considering the x squared, since that's the highest exponent, that would come first. So 3x squared plus 3x minus 3x squared, sorry, plus 3x plus 6. And that's how you would write it. And then in this case, a polynomial with more than one variable is written in alphabetical order. For example, if we had a polynomial that looks like this, well, we wouldn't leave it like that. We would say, okay, so a is before x, so it's minus a squared plus, well, a to the first comes before the x, so it's xa, and then the last term plus x squared. Okay, here's the last thing I want to share with you before I take off. So you're going to be asked to simplify and to add like, and the way you do that is adding like terms. So for instance, if somebody gives you this equation, or this series of terms, minus 2d, minus 2d, minus 2d, plus d squared, minus 5d squared. Well, you can sort of make it into buckets. So there's so many that are in the d bucket, and so many that are in the d squared bucket. And that's really the only 2 buckets you have. So the d bucket has minus 2d, and it has minus 2d, and it has minus 2d. And the d squared bucket has a d squared and a minus 5d squared. So if you add up all the like terms, 2d, negative 2d, minus 2d, minus 2d, this is minus 6d. And here, if you add up d squared and minus 5d squared, that's minus 5d squared plus d squared is minus 4d squared. So if you add them up, you have minus 4d squared minus 6d. And that's your answer. So there you've simplified by adding like terms, and that's what you end up with. So let's do one more example. So 3 plus 2b squared. Well, so let's have it constants. So that's 3 because that's a constant. And b squared, well, there's 2b squared in there. And there's a b, so that's minus 5b minus 2b. And now there's 4b squared, so there's 4b squared here. Okay, well, if we add those together, 4b squared plus 2b squared is 6b squared. And minus 5b minus 2b is minus 7b. And 3 is 3. That's a constant. So if we put these in descending order, so it would be 6b squared minus 7b plus 3. And that's simplified. Okay. Good.